Okay, now we're live. Okay, is this all clear? This normal distribution stuff? I hope so. Let's talk a little bit about some other distribution features which arise from time to time. And one which Phil had pointed out earlier was this notion of skewness. Skewness is a statistic, is a number that you get that summarizes how far you depart from symmetry. So skewness of 0 means that you have a perfectly symmetric distribution. There's no departure from symmetry. And the bigger that skewness number gets, the bigger your departure from symmetry is. The sign of the skewness also is of some use to you. A positive skewness score tells you that the scores, the departure from symmetry are mostly out in the positive direction. So the tail that breaks up the symmetry is one that goes out in the positive direction. That'll produce a positive skewness score. And what you might guess is the skewness thing that produces a negative value goes the opposite way. It might look something like that. Just to give you an example, when I gave an examination at another university, at my home university, in a course that was similar to this, I calculated the skewness of the scores, and it was minus 0.50, and that's the actual distribution of scores. And you can see that it has this longer tail down here in the negative direction. In our university, we use a 4-point grading scale. You can get anything from a 0 to a 4. And here you have this sort of small number of people who got 0s, and a few more that got 1 points, and a few more that got 1.5s. But you don't have that same tail extending out symmetrically in the positive direction. So if somebody told you that the skewness was 1.3, even though you don't know exactly how that's calculated, you know a couple of things. You know, first of all, that the distribution was not perfectly symmetric, and you know that the departure from symmetry was tended out into the positive direction. That gives you some additional information that you didn't have from a mean or a variance or some measure of variability. Right? So skewness is useful sometimes. Another one is multimodality. Particularly when people use the mode as a measure of central tendency, there's the implicit assumption that there is only one mode in question. There is only a single score that is the most frequent score. And that will almost certainly, I take it back, that's often the case when you have a symmetric distribution. It's often the case if you have a single peaked, single mode distribution, that that mode is somewhere near the center of the set of scores. That's why the mode makes some sense as a measure of central tendency. But sometimes you don't have a single mode like that. And here's a visual example of a so-called bimodal distribution. Yeah.
If you had maximum variance, would that also be?
In fact, that's right. In fact, maximal variance, you'd have two big peaks and nothing else. Nothing in between. You wouldn't even have the ramps or the foothills leading up to those peaks. You just have these two spikes at either end of equal height. That would be that instance of maximal variability in the distribution. Right. Exactly. Now, can you tell me what are some variables that are likely to have that kind of bimodal distribution? We just said that things like intelligence and height and weight are distributed normally, which is a single-peaked, single-mode symmetric distribution. Here we have multi-peaked. In this case, it's symmetric. We'd have multi-peaked that were not quite symmetric also. But tell me the kind of thing that you might expect to give rise to this kind of thing.
Yeah. Pregnancy age. So, like, say, the first one's 16 and the next one's 35. Well, when women started to get pregnant, so.
You might say that there's a peak here at the end of fertility where people rush to have children. And there's a peak here at the beginning of fertility when people start having children. Right? That could produce that, yeah. That's a good example, yeah.
Could you have something like days and contact hours at university? So I've got mine split across a Tuesday and a Thursday, 2 on each, so I come up for the week.
So if the dimension here were days of the week,
yeah,
you could have people that says, I've arranged things so the middle of my midweek is not very busy, but my Mondays and Fridays are. Yeah, that could be an example of such a distribution. There's some more prosaic examples than the one you guys come in with, the exotic ones, which are very clever. That's very nice. I'm actually fishing for something more prosaic.
You often see that sort of with hormones. There's often goes like that throughout the world.
That's interesting. With time?
Yeah.
Think about that for a second. You may well, maybe with the circadian rhythm, if we did it on a daily thing, we might find a biurnal kind of pattern where there are 2 peaks for the hormones. Yeah, that's possible.
Things that have to do with like gender differences.
Yeah, what are you thinking of?
I don't really know. I guess like tendency of children to play with certain toys.
You might say that number of hours spent playing with trucks.
Yeah.
In 2-year-olds, and there's a big peak here. There are 2 big peaks, and this turns out to be gender. That the boys are playing with a lot, and the girls are playing relatively little, and you get a bimodal distribution. The really prosaic kind of example I was fishing for are attitudes on sort of controversial subjects. So in my country, for example, if we had the distribution of people's attitudes pro and con towards abortion, we might find a big peak here of people who are very anti-abortion, and another big peak here of people who are very pro-abortion, and then very few people who are indifferent. Yeah.
But wouldn't that be 2 different scales and not the same one?
No, if I could measure this, and for example, saying this point is a very low score means that I feel that the maximum degree of freedom should be given in terms of abortion. You can abort a baby anytime, anywhere, right up to the moment of birth. Yeah. Right. And the other extreme is you never can, under no circumstances, no matter even if the health of the mother is endangered, it's still would not permit. So we took a sort of a measure of how liberal or how much freedom of action a pregnant woman should have in ending her pregnancy. You might find a lot of people who are generally negative, generally restrictive on rights, others who are very non-restrictive on rights. But maybe not a lot of people who are sort of in between. People have, so on attitudinal issues where people have strong opinions one way or the other. But everybody takes sides. Nobody sort of doesn't take a side. Then you'll get these kinds of bimodal distributions. But they arise other times too. But that I think is one of the more common. You guys all came up with good other illustrations of mine, which only goes to say that not everything in nature is a result of a whole bunch of simple random processes, plus minus processes, summing up to produce a final distribution. You can get distributions that have more than 2 modes. I found this one. This is a trimodal distribution, and it actually is an interesting one. It's the distribution of people dying. They get a certain kind of injury, and then the question is, how long do people live? This is the distribution of the length of survival. And what does it say? It says there's the first big peak of deaths come here very early. But if you get past that crisis, it's not that you're home free, that you're going to have a very long life. What happens is that there's, for this injury, tends to be a second point where if you get to that point, another large group of people die at that point. And then you're still not out of the woods. If you manage to survive those 2, then there's a third point here where there's another crisis where a large number of people die. And if you get past all 3 of those, then your chances of longer-term survival are much improved. So if you were a doctor trying to communicate to a patient or to the family of a patient, what's the prognosis? What are the chances of my child surviving this terrible injury? You'd say, well, I could give you an average number of days or weeks of survival. That would be a single central tendency statistic, but that wouldn't be as much useful information as that plus some variability. Is it that everybody lives about that long, or is it some live a little very long and some very... But even that would be insufficient. I could say it's a positively skewed distribution, such that there's a long tail out here, and some people live a long, long time. Despite having... But still, another useful thing would be to tell you about these multiple peaks. To say that, there really are three... We've got to get through 3 crises before you get to the point where we can start expecting you to have any long-term good chances of survival. And that would be the most informative way to communicate the data on this injury. So that you could, as a patient or as a family member, you could say, well, good, we made it past the first one. Now let's see how we do on the second one, and let's see how can we get through this third one. If we make it to the third one, now we're out here in this group that actually tends to survive for a long time. And there really is, at least to my knowledge, there is no simple statistic that communicates this idea of how many modes you have in the distribution, how many peaks you have in the distribution. And probably what you really need in such cases is to be shown the entire distribution. So you can see if there are such multiple peaks, like 2 big peaks or 3 or sometimes more peaks.
I mean, couldn't you otherwise just split up the distribution in 3 parts and just could say, like, for example, the first one is, well, quite normally distributed and it's really hard